Hey guys, Lard here, and in this video we'll start working on our AI for the lightsaber combat. So first of all, let's dig a little bit into the theory. I have a Photoshop open here. I'm gonna share kind of the way how AI works in Unreal. So first of all, till now we've been working in the character blueprint, and the character blueprint is something that extends pawn. And pawn is literally, the name pawn kind of signifies what it's used for, which is if we have a pawn here, let's just call it B, right? We have a pawn here, maybe I don't need that, let's just make it like that. So the pawn is controlled by one of two things, usually. We have this guy, which is player controller, and this is us. And then we have another thing, which is AI controller. And so one of those things is controlling the character. In our case, up until now, we've been using this way. So this is the first way for our character. So our player controller was capturing our keyboard inputs and all this kind of stuff. Now we have to extend this and say that, okay, we can give the control of the character similar to our character to something else, which will be AI controller. And we will go further with this. We will do behavior trees later on. And behavior tree is kind of, somewhere on the side here, it's connected to AI controller. And it's just sitting here kind of with blackboard. So we have a blackboard connected to behavior tree, and we have behavior tree by itself here, and it kind of commands the pawn through the AI controller. But for now, let's just go to this part, to the AI controller part. All right, so we are back in our project. Let's just quickly start it and review what we've done. The tutorial for the slicing, of course, was the last video I posted, and you can see that the basic slicing works here. And of course we'll continue working with slicing as well, but for now I wanted to dedicate this particular tutorial to push in our main agenda, which is lightsaber combat. Okay, so first of all, we have a player controller which controls our pawn, but we also need AI controller now, so that it will control the pawn as well, or our character. So I have in my blueprints an opportunity to create a new one, and I create a blueprint, and the parent class will be AI controller. So AI controller, which is which derives from controller, and AI controller just like that. Let's call it LCC AI controller, yeah. Alright, so for now it's empty. I have it opened here, so you can see it has no code. It's also actor, so you can have the viewport here, but there's no code. And for now, let's make sure that it works. And the way how we do it is we take select our character. This is the character that we automatically possess when we click play. Now let's make another one. Let's just hold Alt and then move the move gizmo to duplicate. And let's put him there and rotate him like 180 degrees. And you can, of course, let go of the Alt as soon as you let go of the mouse to move the duplicate. So now if I click play, I get spawned as this guy. Now I don't particularly remember which logic is used to determine which character I am spawning as. But one thing you can do is if you wanna totally control the way how we are spawning as a player, is we can finally move to full-fledged spawning, which is we delete the character which we possessed automatically. Up until now we have this player start here. Let's make sure that this player start just literally spawns a let's see what's our guy called. It spawns our third-person character and we possess it. So if I delete another third-person character, you don't have to do it. We're just testing for now. So I'm just going to show you what happens. If I click play, you can see that actually by default, player start spawns our player character. So kind of the problem arises if I have, let's see, Control Z doesn't work here. So let's just place the guy here once again. Actually, you know what? The problem doesn't arise, I think, at all. As soon as we delete the initial character, we spawn on our player start and we have this guy here. And this guy here is not sentient in any way, he just stands there. So let me just go ahead and rotate him like that. And maybe move him over here. And again, our player start has an arrow for its direction, so we can go ahead and rotate it. And this should control the direction at which we will be looking at when we're spawning. So now I rotated them towards each other, and you can see that this is exactly what happens. Alright, so now once again, what we have is we are sure that our player start spawns us, and then the guy who is placed in the level is the guy who will presumably be using artificial intelligence for its movements and attacks and everything. So first, one thing you have to keep in mind is that whenever you're using controllers and stuff like that, even game mode, pretty much all the singletons and all the controller classes except for the game instance, all of those things are actually actors. So when you play, you can see them in the world outline. So if I play right now, if I just go ahead and look at my world outline, you can see that these yellow things here, these are the things that have been spawned in the runtime, kind of. So they're not the ones that you placed in the editor, but they are the ones that you got when you started the game. So, and they are required for the game to function in Unreal, as is the Unreal's architecture. So player state, player camera manager, particle event manager, third-person character, which is us. We were spawned in the runtime from the player start. Game mode also is an actor. And you can see AI controller. Now this AI controller belongs to the guy who is in front of us. And you can see that it's AI controller, it's of class AI controller, even though we created a new class, which is LCC_AI controller. So now we have to tell the game that, hey, if you're possessing, because that's how it works, the pawn upper is possessed by the controller. So we have to tell the game, if you're possessing the character or the pawn, this is the class of the pawn that I want you to use. And if we go, actually, okay, the opposite, sorry. This is the class of the AI controller that I want you to use for this pawn. So let's go to our third-person character. You can click it in the content browser, and one more way that I want you to be aware of is that if you click on the blueprint or actually any kind of object on the map and you press Ctrl-E, it's edit. So you will open the blueprint editor. So now we are in the third-person character default settings, or initial values as they are called here. And AI controller class here. This is the class of the controller which will be spawned for this AI, for this character, sorry, in case that the player is not possessing it. So in our case, we're spawning as the player. So the other character just stands there, so the game automatically decides, well, I have to possess it for the AI controller, it makes sense. So we're gonna go ahead here and select our LCC AI controller. And now, play. And you can see in the left, oh sorry, in the right, LCC AI controller is the guy who possesses the character. Okay, so now the first thing ever that you do when you have an AI case in any kind of AI framework, at least this is my kind of logic, I want to make it do random movement, which is move to random point, maybe stop, and then move again. And this is like the pure basics, because this covers already navigation, and this covers the animation for movement. And we're gonna do the same here. So let's go ahead and make sure we have a navigation mesh, because the way how characters move in Unreal is they're using navigation mesh. So if we are in the editor, we can press P to show navigation, and we can see there's no navigation. You can also press in sorry, in the world outline you can search for nav. There is nothing. And so we go to the left, and here we look for nav. We need nav mesh bounce volume. Nav mesh bounce volume, when placed on the level, will automatically spawn the recast nav mesh object, which is navigation data. It's a singleton for the map. So you can see I have 64 actors on the map right now. If I drag and drop this guy, it's 65 and 66 now. So nav mesh bounce volume appeared. It doesn't have much control over, doesn't have much settings. But you can see now I also have recast nav mesh default. Now this guy is just a kind of configuration for the current navigation mesh, or current navigation agent. So you can also enable drawing here. This is the same thing as pressing P. So if you can see I press P, and you can control. It's not supported here to change many settings. It's better if you want to change the navigation settings, you go to project settings, and here we have, let's see, navigation mesh and navigation system. So we're not going to dive too deep into that right now, or at all actually, because default settings are fine for characters of human size. And this is exactly what we have. So for now, I just changed the size of this navigation mesh. Oops. Let's get this kind of angle. And let's just stretch it out so it covers all the territory. And the green area is the area which actually has been computed. So the navigation has been built for this for those areas. And now the characters can move through those. So you can see that it's smart enough to avoid obstacles already, and because my navigation mesh is really low, it doesn't cover the stairs and this upper level, and it's okay, we don't care about this for now. Now we have our navigation system, our navigation mesh up and running. So basically at this point, if AI controller has the character on the navigation mesh, which it has because this guy is placed on the floor and navigation mesh is above the floor, if we just ask it to move somewhere via the navigation, via the AI framework, it will just do that, and it will search for the path via the navigation system. So let's try doing that. We are in the LCC AI controller. This is the guy who possesses our character who is in front of us. And let's see, is there on possess? Yes. Okay, so one thing that you kind of have to be aware in the blueprints, or actually in Unreal in general, it's event-based system. So you are not sure that by the point that event begin play starts, we have already possessed our pawn. But you are sure when it actually calls event on possess, which is something that's called after the pawn is possessed. And this is exactly what we need. We are 100% sure that we have a pawn, and so we can give commands to AI controller. Right click, and let's do something really simple. AI move to. Move to location. Okay. There are several nodes like this one, and we will go through at least a couple of those. This is the simplest one, I believe. So we are just telling, hey, go there. And the destination is a vector, of course, which is a location. So you would ask me, well, how do you get a destination? And remember, if the destination is just somewhere in the air and the AI cannot build a path to it via the navigation mesh, it will just stop in place. And we don't want that. So how do we do that? Well, there is a really handy command that I've been using for years, which is only available in the actors, by the way, because actors have access to the world and navigation system, but it's called get random reachable point in radius. I'm not sure what's the difference between this guy and random point in navigable radius. I'm not sure. If you guys know, please let me know in the comments. I've been using them for years interchangeably, and they've been working fine. So let's take a radius of like 10 meters. And the origin, of course, is the possessed pawn get actor location. So we take our location, and it's an origin, and around 10 meters, in 10 meter radius around us, we get a random point on navigation, which guarantees that we can move there because we can build a path on navigation, and put this into destination. Accept radius -1 means that you will move until you're exactly there, precisely there. Use pathfinding fine. We don't care too much about these guys. Stop on overlap is fine. And partial path means that if you cannot reach it, but you can walk closer to it, you will still do it. So this is as simple as it gets. Let's see if it does anything. And it doesn't. But this is fine. We can go here and print string. So this move to location, of course, prints the result. And the result is, you know, what happened, what is the output of this request right now? Because remember, movement takes time, but this guy is atomic, which means that it immediately gives some kind of result. And if we do switch on this result, you can see it failed, already at goal, or request successful. And request successful means that, yeah, I acknowledge that, I'm gonna get going. Remember, this doesn't take time. This shoots the return value instantly. So even if it starts moving, it's not there yet. So let's see what does it say there. And it says they're failed. We can show the navigation in the runtime by going to console, pressing the tilde button, tilde, I don't remember how it's called in English actually, and then writing show navigation. So you can see that the guy is on the navigation mesh. It just doesn't move for some reason. And this is fine, of course. We can troubleshoot that. One thing you can do, let's put him at least a little bit up, and then see what happens. Nothing. One other thing you can do, of course, is event on possess. We can go ahead and do what? We can just do delay. So this is one thing you can try. For example, right now it's falling down, so of course when it's falling down, it's not able to use navigation yet. So this is a quick trick. I don't think it's gonna work, but we're gonna check anyway, which is if we're switching on the result of move to location, and the only result that we will accept, kind of, which is request successful. Actually, already at goal also makes sense, so let's just print if this is the case. But if it's failed, we're gonna wait 1 second and do it again, right? So let's see. Yeah, okay. So it worked, but not instantly. So it took some time. Event on possess immediately didn't work. One thing we can try is actually revert my previous point and try to do it on begin play. Let's see what happens there. Well, actually on begin play, I think, you know what happened? I think on possess happens before begin play for this controller, which is interesting. So yeah, this is one of those times where I have to tell you, you know, ignore what I told you previously, forget about on possess, and here, actually we don't need it, we don't even need, we need to take pawn's location, of course, so get controlled pawn, get actor location, and just like that. Now this would not work, of course, if we were spawning AI controller by ourselves, because at this point, you know, if we spawn it by ourselves, and then we say, you know, well, I mean, we spawn it and then it happens, begin play happens, but we don't have possessed pawn, this will not work. But in our case, we have a pawn already on the map, it will initialize, it will, you know, spawn actually, it will spawn the AI controller, and then the AI controller begins play, and now it's capable of actually doing movement. Okay, so already at goal we print it, failed we print it, or request successful we don't print it. Let's see what happens. Boom. So it works. I noticed that there is no walk-in animation, this is fine. Okay, so this guy moves in one place, which is a start. So I will wrap up this tutorial, I think, after we do one more thing. And then the next tutorial we'll fix the walk-in and go forth with it, right? Okay, so this thing is atomic, so you cannot actually catch the movement when it reaches the destination. We don't really like that. And there is a way to do it better, which is AI move 2. And this guy is much more advanced in the sense that you actually have control over when it succeeds or fails. Okay, so we give it destination acceptance radius. Let's give it like, I mean, 5 centimeters is fine. It requires pawn. It actually is not a function on the controller. It's a function pawn because it will use the controller. So now we just go ahead, do AI move 2, and you can see it has this small clock. Now this clock means that this task takes time. So if you take execution out of here, this of course is like chaining. This is next command immediately. It will go there atomically. But then after some time it can succeed and it will go out of here, or fail. It will go out of here, and this can take some time, right? So now if it succeeds, let's just do delay like half a second maybe. Oops, I think I will have video freeze right now. Sorry for this, guys. It's my other screen acting all weird. Okay, I hope the recording works fine now once again. Okay, so if it fails, again we just wait and then we try again. Of course, the cool thing about this is that this is a looping execution which will never end. Whether it succeeds or fails, one of those things have to happen. It will then wait and do it again. So let's see how this works. So here he moves, he waits, he moves, he waits, he moves, he waits, and you can see of course that he follows navigation mesh. So there won't be a point in time when he just, you know, gets stuck somewhere, because navigation mesh takes care of, you know, finding the kind of valid point on itself. Okay, so I wanted to make this video shorter, but as you can see, even, you know, explaining kind of how navigation works, how the AI works, and so on, takes time. I'm not sure what happened here. I think he got stuck because, let's see, show navigation. Yeah, he was trying probably to get here, and it didn't fit him. Okay, but you get the point. So in next tutorial we'll cover the movement of the legs and everything, the animation, and maybe get into combat and some other stuff, of course. Thank you for watching, and see you next tutorial.